Good morning, dear students. I welcome you to my physical chemistry class. Let me start with the chemical kinetics first. Before passing on to the kinetics, I wish to give you an overall view of the syllabus included in this chapter. That is kinetics and catalysis. It's a 12 hours class. Kinetics and scope, a rate of reaction, order and molecularity, derivation of rate constant, that is integrated rate constant for first, second, third and zero order reaction with the example. To mention half-life periods, then various methods to determine the order of the reaction, steady state approximation, that is the elementary idea of parallel reaction, opposing reaction, consecutive reaction and chain reaction with the example, and effective temperature on reaction rate, Arrhenius equation, determination and significance of Arrhenius parameters, theories of reaction rate, collision theory, derivation of rate equation for bimolecular reaction using the collision theory. Then transition state theory, otherwise called activated complex theory, expression for rate constant based on this theory and its thermodynamic aspects. Then Lindemann mechanism or Lindemann theory of unimolecular reaction. And the catalysis include homogeneous and heterogeneous catalysis, theories of homogeneous and heterogeneous catalysis, and the theories of enzyme catalysis, that is Michaelis-Menten equation. So these are the various aspects of the syllabus we have to discuss within 12 hours. So let me start with the chemical kinetics. The phrase chemical kinetics, otherwise called reaction dynamics, is often abbreviated as kinetics. It is concerned with the detailed study of the rate of chemical reaction and the factors affecting the reaction. Okay. That is, when you look around, as we can see, or you are familiar with the various types of reaction, which all are taking place or progressing at a definite rate. And this aspect of the rate of the reaction is actually discussed in the kinetics. That is, we have to measure this rate and the factors affecting the rate and the theory behind this rate. All these are discussed in the chemical kinetics. It actually involves the quantitative study of the concentration changes with time due to the chemical reaction. And the research data are summarized in the form of an expression called rate expression. Okay, that is the broad aspect of the chemical kinetics is an experimental part of measuring the rate and collect the rate data and it converted in the form of a rate expression according to observation. And as you know, during the chemical reaction, the bonds among the reactants are broken and new bonds are formed in the products. That is, there is a so-called rearrangements of the bonds have taken place between the reactants and products. Thereby, knowing this aspect in the rate determining step, okay, by knowing which bonds have undergone breakage in the rate determining step, we can propose the reaction mechanism of a reaction. Thus, kinetics generally form the backbone of a thorough mechanistic investigation. The experimental part of the subject deals with the ways of measuring precisely the rate of reaction at various temperatures. The important steps in any kinetic investigation are: 1. The collection of kinetic data. Okay, the collection of kinetic data after carrying the experiment. And second, establishment of the relationship between rate and reaction mixture composition. And 3. Interpretation of the collected data to arrive at mechanism. These are the 3 important aspects involved in the kinetics. As you know, we can have, or if we are familiar with the different types of reaction, that is slow and fast reaction. Slow reactions, the reaction which proceeds at very low speed. It takes hours or even days to complete. Example, rusting of iron. And fast reaction, these are certain reactions which takes place very rapidly within a time of less than millisecond, that is less than 10⁻³ seconds. Example are ionic reaction, the reaction between silver nitrate and sodium chloride, neutralization of between acid and base, that is called neutralization reaction. In between these two extremes, there are certain reactions of moderate rate proceed at measurable speed. Example, ester hydrolysis, inversion of cane sugar, and oxidation of certain organic compounds. So let me stop now. Thank you very much.